Is it a cat or a dog? Will the customer buy or not? These are classification problems, right? So the most standard tool to solve them is a logistic regression. Today we'll break down the math behind it and use the logistic function to calculate a real probability. So the mechanism, what is the mechanism behind the logistic regression? So logistic regression is actually a two-step process. Step 1, it acts like a linear regression. It takes your input x, multiplies it by the weight and adds a bias and gives you a score. The problem, the score can be anything, negatively infinity to positive infinity. Probabilities must be between 0 and 1, right? We can't do that thing, infinity things, right? So the step 2 is to fix this with the help of sigmoid functions, right? So the sigmoid function formula is, you can see on the screen, is 1 upon 1 plus e to the power exponential to the power minus z. This formula takes the wild score z and squashes it. A huge positive number becomes 1. A huge negative number becomes 0. And 0 becomes exactly 0.05. So let's try to concentrate an example. We want to predict if a student passes based on our study, right? So if we check the inputs, the weight is 0.5, the bias is -4, and the input is 3. So here the weight is 0.5 and the bias is -4. Our student studied for 3 hours. First calculate the linear score, which is 1.5 times 3 minus 4.2, which is 0.05. So z is equal to 0.05, right? Now plug that into the sigmoid function and the result is 62.25%. Since this is greater than 50%, the model predicts as pass, right? Down right here. Yes, it passed. So watch what happens if the student only studies for 1 hour, right? So the linear score becomes negative 1.5 times minus 2.5. Let me, so the sigmoid squashes the negative number to 7.5, right? So if I decrease it a bit, right, rather than changing the values, if I go to for 1, he just studied for before he studied for 3 hours. Yes, so let me make this as 1. We should not change the weights, right? Yes. So if he studied for just an hour, the sigmoid function squashes that negative number down to 7.5 or 7.59, I should say. So the model says he will fail, man. 1 hour study, not enough. So that S curve you see on the graph, that is the logistic function in action, mapping every possible input to a validating probability. So if we change the weights, the S curve will change, but we should not change the weights until unless the model is in training mode. But we can change the input to see that as the hours increases, the student passing thing also increases. But after, like, if I do like crazy amount of study for 20 hours, it will not just change anything, right? It will just bypass the whole model. Actually, this model is not that much smart, but if I say go for 5, still 97%, and if I go for 3 or 4, yeah, so 95, 88, similar, right? 1 hour difference, just making a not that much difference, right? So we can see with that, right? This was all about the logistic regression. It's just a straight line wrapped in a S curve, sigmoid. Thank you.